That's really sad. So far, we have been looking at populations whose initial values were 1. For example, the orange, yellow, and green skeeter populations. The equations were always y equals 1 times b to the x. But in the next activity, we're going to look at skeeter populations whose initial values are not 1. So what did the 1 represent in the above equation? The initial value or population? So it stands to reason that if we have a population whose initial population is something other than 1, then we should simply replace the 1 with that value. Example 1, you have a skeeter population that is growing by a factor of 3, and the initial population is 2 instead of 1. Fill in for the chart for the population up to shape 5. So at shape 0, how many should we have? 2. If we're growing by a factor of 3, how are we going to find the next population? Three times what?
Or assume that you to the.
Would it be 2 to the third?
No, it's not 2 to the third. What's our previous population?
2.
And our factor is?
3.
So how do we find the next population? It's 6. How do we get 6? 2 times 3. Okay, so then what do we do to find out the next population?
6 times 3.
Yes. Which gives us?
18.
Next population is?
18 times 3.
Which gives us?
I have no idea.
Calculator would
Hold
be
on.
telling me right now.
I got
54.
Really?
162.
That's not mad shit.
165.
2.
$9.
Oh, I goes off. I had an extra number.
46.
Oh my god. I can't do it. I can't keep up.
Wait.
All right, now, shake number 5 is 162 times 3. All right, now we need to write the equation that we think would correspond with this data. So y equals, what's our initial population?
3.
Is it 3 or 2?
2.
Times 3 to the x. Check to see if you've written the correct equation by substituting the values 0 through 5 for x. So y equals 2 times 3 to the 0 power. What's 3 to the 0 power?
1.
1 times 2 gives us 2. So what this means is that shape 0, we should have a population of 2. Do we? Okay? Y equals 2 times 3 to the first. So 3 to the first power is? 3 times 2 is? So at shape 1, do we have a population of 6?
Yes.
Y equals 2 times 3 to the second power. 3 squared is? 9 times 2 is? Do we have 18? Y equals 2 times 3 squared. Cubed, sorry. 3 cubed is?
18.
No?
27.
27. And 27 times 2 is? 54. So do we have 54 for our third shape? Okay. Is our equation correct? The equation y equals a times b to the x, this is really important, is the same as before except a represents the initial population. Before, we were always given 1 for the initial population. So represented the initial population before, but now we're going to have values other than 1 to start off with. Jessica invested in an account that promised a 3.8% growth rate per year. Using an equation of the form y equals a times b to the x to model the situation, what is the value of b? So we have a growth rate of 3.8%. We're asked to find the value of b. What's the relationship between b and the factor? B is the factor. So how do we find the factor if we're given the growth rate?
Turn it into a decimal, and then it's 1 more.
Okay? So 3.8% is equal to what as a decimal?
0.3.
Point 0.03. Thank you. And the factor has what relationship with the growth rate? 1 more. So that means that our factor will be what?
1.038.
Very good. All right, B asks us to predict the value of Jessica's account in each of the next 5 years if she invested $2,000. Round each value to the nearest cent. So for year 0, what's my initial value? So for my value for year 1, what do I do? What did I do on the example above? Okay. So 2,000 times the factor, 1.038, gives us what?
2076.
Okay. So now I take 2,076, multiply it by 1.038, and that gives us
4,154 and 89 cents.
To the nearest cent.
yes. All right, now there's another way that I could determine this. Can I write an equation for this? Okay. So what's my initial value?
2,000.
2,000. So y equals 2,000 times, what's my value of b?
1.038.
To the x. So for the 3rd year, I have y equals 2,000 times 1.038, and what power do I raise it to? What power?
3,
Why 3?
because that's the year.
That's the year. So 2,000 times 1.038 to the 3rd gives us how much value? Okay. So for year 4, y equals 2,000 times 1.038, and I'm going to raise it to what power?
4.
Gives us what value?
2,321.77.
And year 5, y equals 2,000 times 1.038 to what power?
5.
And it gives us?
2,400, or, yeah, 2,410.
Thank you. For each growth rate below, determine the value of b and the corresponding equation of y equals a times b to the x. So what do we ask to find for all of these?
The value of b.
The value of b, and we're given the what? Growth rate. So the b is the same thing as the what? Factor. B is representing the factor. And the factor has what relationship with the growth rate?
It's 1 more.
1 more. Factor is 1 plus the growth rate. So I have 90% for my growth rate. What do I need to do with this first? Okay. So
The decimal is 0.9
0.9.
plus 1.
so my factor is going to be
1.9.
1.9. B, what is it as a decimal? 0.03, so that means my factor will be
1.03.
very good. And C, 115%.
1.15.
So my factor is
2.15.
very good. For each of the following values of b in the equation of the form y equals a times b to the x, determine the growth rate per time period. So on 4, what are we asked to find?
Would you turn it into a percent?
Growth rate. And what are we given?
The factor.
You subtract 1 and turn it
Factor.
into percent.
Yes. So we have b, we're going to subtract 1, and that'll give us the growth rate.
That's my mom.
All right, so for A, what am I going to do first?
Oh.
For A, what am I going to do first?
Minus 1.
Subtract
Subtract 1,
one.
so it'd be 0.4, and then that would turn into 40%.
Very good. Are you grounded?
No.
You're welcome.
She said I have a meeting after school, so I can ride the bus home or I can stay for the meeting.
Fine.
All right, B, 3.6. What am I going to do first?
Subtract 1, so we...
Gives me what?
2.6.
Which is?
Wait.
0.02.
Hold on here.
Isn't it 200?
Yes.
Me?
C, what am I going to do?
Subtract 1.
Which gives me?
0.05,
Which
which
is?
is 5%.
Very nice. Dominique's on her game today.
Hey, Mauer.
Yes.
How do you feel?
I feel great.
What is
All right.
it about?
Yes,
Freedom
sir.
Academy, whatever it's called, I don't know.
Learning to lead yesterday. All right, given an initial value of 12 and annual growth rates of 4%, determine the values for each of the next 5 years. So, let's write an equation.
Kelly, you make so many sense.
What are the things that we need to write in the equation? What are the 2 things that we need to write the equation?
The growth rate.
B and the...
A and B.
A and B. A represents
We're recording.
The initial population.
initial population and B represents the factor.
Okay.
All right, so y equals a times b to the x. So what is my a?
12.
12. What's my growth rate?
0.04.
0.04. So that means my factor is,
1.04.
all right.
Good job, Walt.
So for year 0, what is my value?
4.
No.
Wait, what is your
12.
what?
My value for year
It'd
0.
just be 12.
It'd be 12. So for year 1, I have 12 times 1.04 to what power?
It'd be
first.
1. The first one.
Which gives me a value of what?
I need to get on my
Awesome.
12.4.
Yes.
Austin's always got one.
All right, for year 2, I have 12 times 1.04 to the what power? Yes? And that gives me a value of?
12.9.
Third year, 12 times 1.04 to what power?
3.
Which gives me a value of?
13.5.
Awesome. Put it down.
Yeah.
12 times 1.04 to the fourth, which gives us a value of?
14.03.
4.
04.
12
whatever.
times 1.04 to the fifth power gives us
14.60.
Poor Julie. She's like, fine.
fine. All right, nice job.